Here we wish to design a non-inverting amplifier with a gain of 6, assuming that we have an ideal op-amp. So if we want a non-inverting amplifier, this is the circuit that is a non-inverting amplifier circuit. Our signal voltage is being applied at the non-inverting terminal, and then we have our feedback at the inverting terminal. We just saw that the gain for a non-inverting op-amp is thus. And so if we want a gain of 6, that means that this value here has to equal 6. So if we're trying to pick two values of RS and RF to get us this behavior, we need to simplify that relationship between them a little bit more. We can say, if we have a fraction here, we can make the 6 over 1 a fraction as well, so that we can cross multiply. And then we'll have so we see here that we have our feedback resistance RF should be 5 times as big as RS. If we are designing, we can design this to be any value that we want, but typically we want to use standard values just for simplicity and economy in our production and manufacturing process. So we have this relationship between our resistors, but we want to use our standard resistors, again, for ease of access. Here is our table of common resistor values. It would be really nice if we could find one resistor and then another that's 5 times as much, but if we look down the lists, most of these are multiples other than 5 of one another. If we look across, we see that there's a factor of 10 and a factor of 10 and a factor of 10. That's too much. We're looking for 5. But what we can do here is say that if we take a factor of 10 here, if we put two 1K resistors in series, that would give us 2K, and 2K and 10K would be a factor of 5. So what we could do here is say that RS could be 2 kiloohms. In a manufacturing process, this would be a 1 kiloohm plus another 1 kiloohm. And then our RF would be 10 kiloohms. And so that way our RF would be 10 times as much as RS, 5 times as much as RS, as we saw has to be the case here. Also, these values are the most common ones. They keep the current down in safer levels, and so if you're looking to default, these are kind of the middle of the road resistors that you'd want to use. So for part B, we're told that our signal voltage is going to be between negative 1.5 volts and 1.5 volts, and we want to know what are the smallest power supply voltages, VCC, that we can use so that these resistors will keep us in the linear region, so that we'll avoid saturation. And remember that our requirement to avoid saturation means that our output voltage has to be less than the supply voltages. So also our output voltage is our gain times our input voltage. We just found the gain to be 6. That was the point of our design. And we're told that our input voltage is going to be between plus and minus 1.5 volts. If we have 1.5 volts multiplied by 6 as our gain, then our output is going to be plus or minus 9 volts. So that means that our signal voltage has to be greater than 9 volts in order to keep the op-amp in the linear region.